We are recording. All right. Hi, everyone. Welcome back for the day 2 of our online bootcamp event. This time happening as a pre-event of Autodesk University 2022. I see mostly the same names in our attendee list, but for those of you who may be joining us here for the first time this week, my name is Peter Bras. I'm a Forge developer advocate based in Czech Republic in Central Europe. So our team, the developer advocates, were spread all over the world, and our main job is really to help developers who are either getting started with Autodesk Forge or who are already deep in the platform and maybe need some technical support with some advanced topics. And we do help our customers, we help you in different ways. You may have seen us on Stack Overflow. We're trying to be very active there. We run all sorts of events like this one, the online bootcamp. We run Forge accelerators. We write blog posts. We have coffee talks and different types of webinars as well. So again, our job is really to help you guys who are either starting or already deep in the Autodesk Forge platform and you want to build something on top of it. This event itself, the online bootcamp, is really meant for the beginners, for people who are just getting started with the Autodesk Forge platform and who, instead of reading through tutorials on their own, maybe prefer a more guided, more interactive approach where you watch us code or go through a tutorial, and we can explain some more details along the way as we proceed, and we can answer your questions if something is not clear, or maybe if you get stuck on something as you follow our steps. All right, and again, a quick recap. This event is a 4-day event where every day we cover a different topic, a different tutorial. Yesterday, we were covering the simple viewer tutorial, which was like a tutorial that guided you through the implementation of a simple Forge application where you are able to upload and preview your own designs. Today, we're going to be looking at a different tutorial, a slightly different one, where we'll be connecting to existing design data that our applications users may already have in some other Forge-based products. We run these webinars typically in both for our European audience right now, and then we have the same one led by my colleagues in the US for the Americas audience. And with the only exception of Thursday, tomorrow, when I'll be teaching the dashboards tutorial, which is really the same for no matter what programming language you choose for the server side, we typically run these webinars in parallel as well for both the .NET and Node.js. So just as we're starting our Node.js Day 2 webinar right now, my colleague Adam Nagy from UK is starting a .NET tutorial for webinar for the same tutorial. And the way it works, again, we're trying to keep this very interactive. We basically want to show you how we go through a tutorial, how we code using one of our tutorials. We would like you to try and follow our steps and let us know if you run into any problems or if something is not clear, why something is done the way it is. So please try and use the features of the Zoom client. You have the option to chat with us, to ask questions. You should even be able to give us some indications like a hands up or thumbs up, thumbs down, something's not all right, or if you want us to go faster or slow down, try and use all of these features. We really want this to be interactive, right? Because you came and joined us because, again, you prefer this interactive approach as opposed to just you reading through a tutorial on your own. So let's make it interactive. If you have any questions, ask away. If something is not clear, you get stuck, let me know and I'll do my best to help. Also, all these recordings are being recorded and will be shared with you after the event. So don't worry if you miss something that you think was really important, something you would like to get back to. You will have the opportunity to review our webinars probably sometime next week. All right. The topic for today, for Wednesday, is a tutorial we call a Hubs browser. It's very similar to what we were building yesterday, that simple application where you could upload and preview your own designs. But this time, we're going to be using something called a three-legged authentication. I will explain what that means later when we get to that point. But we're basically going to be building an application that will be able to preview existing designs that your users may already have in some of the other products built on top of Forge. So imagine that, let's say you have customers, you have a company that has all of their designs inside BIM 360 or in BIM 360 docs, right? And maybe you would like to build a custom application where they would be able to load their existing designs from BIM 360 and do something special with them. Something where you would add a custom value, right? That would be the added value of your application. Maybe the customers could, I don't know, combine their design data from BIM 360 with point cloud scans, for example. So instead of your customers having to upload all their designs by hand again, instead, this Hubs browser tutorial will show us how to build an application where your app can actually ask its users for permission to load their designs from BIM 360, from Fusion Team, from Autodesk Construction Cloud, or any products built using Forge. All right, that is the description of what we're going to be building today. This is what the application will look like. Again, it's very similar to the one we built on day one, with the only exception where we're actually going to be presented. We won't have an option to upload designs this time, but we'll be presented with the tree view of different existing designs that our user may already have access to in other Forge-based applications and systems. So your user can then simply browse through the tree and select the design that they want to preview. And again, in future, you can use this as a starting point, and then you can start adding your own custom functionality. For example, you want to build, I don't know, a spare parts catalog connected to SAP, for example, right? You could use this as a starting point so that your users, the users of your application that you develop, can select one of their existing models from BIM 360, let's say, or from Fusion Teams, and then you can customize this application so that it brings information about the stock, quantity, and cost from an ERP system and displays the data in the context of the design in your own Forge application. I hope that makes sense. Now, as for the schedule for today, we have a rough 4-section agenda here, but this is very approximate, very vague, because as we said earlier, in the past, we used to run these events that were more with a more strict schedule, where we had an hour to cover one section and then 30 minutes break, then 1 hour to cover another section, 30-minute breaks, a break, etc., etc. This time, we really want to try do it differently and make it more flexible, more interactive. And as I was saying earlier, yesterday, having you guys decide how fast we go. So just take these as a very rough estimate approximation. We will have these still these 4 sections that our tutorial is split into, but it's totally up to you. You decide how fast we go, when we take breaks, and so on. All right, and with that, we can move to the first section of our tutorial, and that is the intro and setup. This is going to be very similar to how we started our day 1 presentation. Again, what you will need is a Forge account. If you don't have one, and Forge app credentials. So let me explain one more time what that is. Forge account, if you don't have one, let me log out. If you don't have a Forge account yet, you can use this orange button, sign up to try Forge. That will create a new trial subscription for you that lasts for 3 months. So you can start experimenting with Forge. You can experiment with it for 3 months, and then eventually you can consider switching over to a paid subscription where some of these services, some of the operations that you do inside Forge are monetized, or some of them cost something. You can find more details on that in the pricing tab on the Forge developer portal, forge.autodesk.com. So if you don't have an account, please go ahead and create one. Otherwise, simply log in. I will log in with my personal email. And then under your profile menu in the application, you should see the applications link that will take you to your list of existing applications. Your list might be empty. I already have a couple of apps. So here, I would just ask you if you can either reuse the application you created during day one, or if you haven't done so, you can just create a new application now. The way it works is you just hit the create application button. You just give your application some kind of a name so that you can identify it easily later on. And this time, there's going to be one thing that's going to be really, really important. Definitely what you want to do is store your client credentials. So client ID and client secret. These are your application's username and password that your application will use when communicating with Forge, because Forge servers will refuse to answer any questions, any requests from your application unless it can authenticate itself, because Forge needs to know who that application belongs to that is running on some server. So we need to make sure to pass these client ID and client secret credentials to our application so that the application can use it when communicating with Forge. That's the same thing we covered on day one. But for today, there is one important difference or an extra step that needs to be taken. And it has to do with callback URL under the general settings. A callback URL is a concept related to this three-legged authentication that I mentioned earlier. And this is something that we should probably cover now. So when communicating with Forge, let me actually open the documentation on the Forge dev portal and look at the authentication. All right, let's see, developer's guide. I think we had a diagram somewhere in here. Maybe not. Anyways, when communicating with the Forge servers, you have the option of either using something called a two-legged authentication or a three-legged authentication. And to quickly recap, a two-legged authentication basically means the process where your custom application that you develop will establish trust with Forge platform. So it's just two parties, two legs, establishing trust between themselves. This is typically done through the process of your application sending a special request to Forge with the client ID and client secret. That would be the authenticate request. And in response to this request, Forge will send back something called an access token. So it's a long string that is valid for 60 minutes, and that has been created for a specific set of operations that you specify in this authenticate request. So here you always specify a list of so-called scopes saying, these are the operations I want this token to be able to execute. So this is a way of controlling, mitigating, or controlling access level when you're generating a token, right? Because maybe you want to generate a token for someone, but for some service, but you don't want to allow that service to delete your data. You only want to allow that service to read your data. And that is done through this list of scopes, so that you can, for example, pass a scope called data read, which will only allow the token that's generated to only read data, not manipulate or create or overwrite or delete it. That is the two-legged authentication workflow, right? You send this authenticate request with scopes and your Forge application credentials to Forge, and Forge responds with an access token that you can then use when communicating with other services inside Forge. This works. This is the standard authentication process that is typically handled when you want your Forge application to just manage its own data, when you're not planning to actually access your users' data from other Forge products. If you do want to access your users' data from other products, such as BIM 360 or Autodesk Construction Cloud, you will want to use the three-legged context. Three-legged, as you might have guessed from the name, it actually involves three parties that establish the trust among themselves. It's your application, the Forge platform, and the user. And the way this works is through a couple more steps. So it's not just a single request to Forge where you get back an access token. This time, in a three-legged authentication, what happens is your application, your Forge application, will redirect a user, for example, when they click a login button, to Autodesk servers. So you can imagine your user will be redirected to some domain of auth.autodesk.com. On that website, your user will be prompted to log in with their Autodesk account, with their Autodesk credentials, the same ones that they would use to log into BIM 360 or Fusion Teams or ACC. And if the user signs in, logs in successfully, Autodesk will redirect the user, the browser, back to some URL where your application will be waiting to receive some sort of a temporary code. And this code can then be exchanged for access token. So it's a bit more involved, a couple more steps, but this is handled, again, in order to allow to establish the trust between the three parties, and then to safely obtain a token, an access token that your Forge application can then use to access the user's data. So we'll basically need to ask the user to give us permission to access their data in other products, like in BIM 360 or Fusion Teams. And that's what that brings us back to the callback URL in your application's general settings. This is the URL where we want Autodesk to redirect the user after they log in, right? So imagine that for now, our application is going to be running on localhost. So it's fine to keep this on a localhost 8080, but eventually, maybe when you deploy your application to Heroku, or maybe to your own custom domain, something like, www.mybimapplication.com, then you'll want to make sure that the callback URL, the mybimapplication.com, will be mentioned here as well. In the past, we only allowed a single callback URL, which was a bit unfortunate, because when you were developing an application and you also had the same app in production, you would have to set this callback URL back and forth. But now, very recently, we've added this option to actually create multiple callback URLs. So you can create a new one. You can keep one for, let's say, localhost for local development, and then you can have one with mybimapp.com, for example, if you decide to deploy your application to a custom domain. So be careful. It's really important to pay attention to this callback URL and how we set it up. We will actually use a slightly different URL, not just localhost :8080. We will actually ask Autodesk to redirect the user to a specific endpoint that will look something like this. Because as we will be developing our server application, we will implement a logic to handle this endpoint, /API/auth/callback. This is where our server will be expecting some response from the Autodesk server when the user is when the user logs in and is redirected back to our application. So please, for now, let me copy this callback URL in the chat. And for now, please set your callback URL to exactly this address, localhost 8080/API/auth/callback. And don't forget to save the changes when you're done. All right, so this is for our application. And now we can, let's go back to our slides. One more thing to mention here. So I've been talking about these other, additional products built on top of Forge, like BIM 360, Fusion Team, or ACC, which is an acronym for Autodesk Construction Cloud. Now, in order to allow your application to access your users' data, there is actually one more step that needs to be done. Because depending on, can I open the link? Oh, yeah. Because depending on the application whose data I'm trying to access from my own Forge app, certain applications require something like a whitelisting, where sometimes, for example, for BIM 360, our application cannot automatically access data in BIM 360 just without doing anything else. What needs to happen first is some administrator in BIM 360 needs to allow our application, enable our application to access data in that BIM 360 project. So this will all be explained in the Forge tutorials website that we're going to be using today in the Getting Started section. Let me send you a link for this as well. Oh, and I see I didn't send the callback URL to everyone, just to post. So here's the callback URL. So you'll see here process that will need to be done. For example, here in Autodesk Construction Cloud, if we want to allow a specific Forge application with a specific callback ID to access our users' data in a specific ACC or BIM 360 project, we will need to go through account administration and BIM 360 administration. And then we'll need to add something called custom integration. So as an administrator of BIM 360 or of Autodesk Construction Cloud project, you have the ability to add a custom integration. And what that means is you simply add client ID of a Forge application that you want to allow to access your users' data. So this applies to BIM 360 and ACC. It does not apply to Fusion Teams, for example. In Fusion Teams, this whitelisting is not required. So, but I just want you to know, if you want to eventually use your application that we built today to access your users' data in BIM 360 or Autodesk Construction Cloud, this step will be necessary. This custom integration where your project's admin will need to add your Forge client ID as a custom integration. When that happens, your app will then be able to see the user's data from that BIM 360 or ACC project. I hope that's clear, and we can we can move on to the dev environment. Again, just like yesterday, we're going to be using Node.js, and we recommend using the long-term support version, which today is, I believe, 16.17, was it? Node.js.org, 16.17. That's the long-term support version. So if you don't have it, please go ahead and install it on your machine. If you are on a Unix-like system, you should be able to open a terminal. I'm on a Mac, and my terminal looks kind of like this. And after installing Node, you should be able to try this command node-v to get the version of the currently installed Node.js runtime. If you're on Windows, after installing Node.js, you should also see the Node.js command prompt somewhere in the start menu. And the command prompt should open a similar looking terminal where you should be able to do the same thing, check the version of Node and also check the version of npm. Or check if it actually is available, this command. npm stands for Node.js Package Manager, and it's a utility for managing your project's dependencies mainly. So imagine, again, if you're building a Node.js application and you maybe want to reuse some of the many external modules that are Node.js modules that are available today. If I look at npm actually has a large registry of packages that you use and you can search through and install and use in your own Node.js application. One of those we'll be using today, again, is the Express, for example. This is an Node.js module for that provides a web framework. So this is something we can use in our Node.js application to be able to quickly and easily develop a fully functioning web server that can serve static files, or they can process incoming requests based on custom content types, that can handle custom URLs and endpoints that we make requests to, things like that. So there are millions and millions of packages in the npm registry, and we can also install these using the npm command line tool. That actually is what we're going to be doing today. All right, that is for Node.js. And for the code editor, we'll be using Visual Studio Code. And just like what I was saying yesterday during day one, you're free to use whichever code editor you're most comfortable with. But just keep in mind that there are some steps that we'll be covering in our tutorial that are specific to Visual Studio Code. So you're free to use Visual Studio or WebStorm or any other editor if you're more comfortable with that one. But then, for example, in order to run the application and to your Node.js application, and in order to pass configuration parameters to it, you may need slightly different steps, right? So we'll be showing how to set up and how to debug our application and how to pass environment variables to it inside Visual Studio Code. And you're free to use other editors, but then you'll need to, of course, you'll need to take a different path, different way to pass environment variables to your application. Visual Studio Code is free, it's open source. You can grab it from code.visualstudio.com. And just grab the latest stable build. When you install Visual Studio Code, it should look something like this. So it's like a more lightweight version of Visual Studio. This one it's cross-platform, and it's really good for web development, in my opinion. So that's what we'll be using today. All right. That is it for our first of the 4 sections. Are there any questions? I don't expect there would be, because most of you guys I see on the list you already joined me yesterday. So I'm assuming that you are all set in terms of the setup of your dev environment and creating a Forge application. But still, if any of you got stuck on anything, please let me know. Otherwise, let's decide what we want to do next. Do you want to take a quick break, or you want to proceed right away? We used a polling yesterday, so let me see if I can get that going. A poll to do next. What to do next? Take 30-minute break. Take 15-minute break, or continue. right away. All right. So let's see, let me launch the poll. All right. So let me know what you prefer, if you want to take a quick break or just continue. Let's wait for a little while more. Ooh, and we got 50-50 between taking a 15-minute break and continuing. Oh, and we now, okay. It's been decided. Majority would prefer a 15-minute break. So I will go grab something to drink as well here, and I'll see you all back here in 15 minutes. So right now my time is 10:33, so I'll see you all back here at 10:48 my time, so 15 minutes from now. All right, and I'll see you later. And we're back. Cool. Welcome back for the second section of our tutorial, of our presentation today. This time we're gonna scaffold and prepare some basic setup for our Node.js server application, and we'll also handle the authentication workflow, which again, as I mentioned earlier, is going to be a little bit more involved today. Let's take a look at it. The client server architecture is the same. Again, we'll be building a server application that will, first of all, serve some static files to our browser, so some HTML, JavaScript, and CSS style sheets. And it'll also act as this sort of a middleman or a proxy when making requests to the fork servers. So our application, our browser, will not talk directly to fork servers, at least not the part where we, the sidebar where we list, where we browse through the project's data. All this information will be actually fetched from our server. So this again is a common workflow, common practice, because this then allows you to customize your server-side code to maybe filter and limit the amount of data that the client can actually receive when the data is requested through the server component. The other important diagram, this is the one I was trying to find in the documentation, but I couldn't, is this one about the three-legged authentication. So again, this explains the process of the three-legged auth workflow, where it's not just your application and Forge establishing the trust, it's your user as well, giving your application permission to access their data. So it starts by the application redirecting the user to the login page on the Autodesk website. And in there, the user will first of all log in with their Autodesk credentials, and they will provide a consent with the scopes that we're trying to get their approval for. So again, we're coming back to this idea of scopes, where different types of operations in Forge may require different scopes. So for example, if you try to simply read a list of folders from a project or a list of files from a folder, all that's needed is just a data read scope, data read scope. But if we wanted to maybe improve our application to also support uploading new files, we would also need to ask the user for permission to actually create new data, create new files. So for that, we would need the data create scope. So based on the scopes that we specify, when we are redirecting the user to the login website, the user would then actually see the list of operations that the application is asking for permissions, right? So I would be redirected to the login page, I would enter my credentials, and then I would see this Forge application is asking for your permission to read data, write data, and potentially some other operations. And when the user does provide their consent, the user in the browser will be redirected back to this special URL. That's the callback URL that we've configured on the application page in forge.autodesk.com. And when Autodesk redirects the user to our application, so this, let's say in our case, /API/auth/callback, Autodesk will also include a temporary code in the request. And that code we can then exchange using the get token request, exchange the temporary code for an actual access token. So that's the workflow we're going to be implementing. All right. So now we're going to be following the Hubs browser tutorial from our Forge tutorials website, this one. Let me send you a link in the chat. This is the application we'll be building today. You also have access to complete implementation of this app for both Node.js and .NET. So again, at the end of the day, if maybe you find out that something isn't working as expected, you can always go back to the tutorials and take a look at either the Node.js or .NET version of the sample, and maybe use it as a reference and compare and see what's different there. All right, we start with scaffolding our Node.js application. So in my case, what I usually do is for this, I just use the terminal or the command prompt. So let me go to a folder that I prepared for today for myself. And what you'll want to do is either using the terminal, command prompt, or just Windows Explorer, just create an empty folder that will be our project folder. So I'm going to create one folder here, call it maybe Hubs browser. So Hubs browser is going to be my project folder. This is where we're going to build our application. And inside this folder, we'll want to initialize our Node.js application. This we will do from terminal or from command prompt. Actually, let me make the font a little bit larger. I'm hoping you can all see it, but just in case. I'm going to type npm init-y. npm init will initialize our Node.js application, and it may ask some questions along the way, but we can actually skip all these questions and leave them all answered with the default values by passing this -y parameter. And when that is done, you'll see that there is a package JSON file that was created by the npm tool in our folder. Now, what we'll also want to do is install dependencies for our application. And even this time, we will again have 3 dependencies. We will use Express. That is the Express.js framework that we will use to quickly build a fully functioning web server. We will use the Forge APIs is again the Node.js Forge SDK that we will use so that we don't have to build HTTP requests that are sent to Forge servers. We don't need to worry about setting the right query parameter, setting the right payload structure. When we use the Forge SDKs for Node.js, we will just basically make a function call or a method call, and under the hood, that will take care of creating this proper HTTP request with correct structure. It'll send it to Forge servers, and it'll also check the HTTP response codes to let us know if maybe something was wrong. So it's a convenience layer right on top of just, we don't need to go low-level build HTTP requests, but using the Forge SDKs, it's basically just a matter of making method calls. And this time we're also installing another dependency called cookie session. So cookies are a common way in web development for a server to store some information per user, right? The way it works is that when you visit certain website, the website can respond with some cookies that will get stored in your browser's cache. And so then later on, when you, let's say next week or the next day, when you come back to the website, the cookies will be sent back to the server so that the server actually knows who you are. And so let's say if you added some items, let's say you went to an e-shop and you added some items to a shopping cart, the website can store the information for you. It can store the items you added to the shopping cart, but it needs to know who you are so that later on, if you come back 1 or 2 days later, you can still see your items in the shopping cart. That's handled through cookies. And in our case, we'll be installing the cookie session Node.js module that's basically, again, a middleware to Express.js framework. And it'll help us, it'll automatically set and read cookies for us. It's one of those benefits of the Express.js framework, where it's nicely extensible through these, again, so-called middlewares. So middleware is a piece of function that you can imagine sitting somewhere in a stack that handles all incoming HTTP requests and all the outgoing HTTP responses. So instead of us having to manually look into every incoming HTTP request to see if there are any cookies, we will actually use just a middleware that already exists called cookie session. And this one will read any cookies automatically for us for every incoming HTTP request. And we will use the cookies here to remember information about our logged in user. Imagine if you log into your application, your Forge application with your Autodesk credentials, and then 2 days later you come back, you wouldn't want to have to log in again, right? That is why we will use the cookies to actually store the access token, the information about your login in the cookie, so that if you visit the Forge application 1 week later, you will still be logged in. So that's the 3 dependencies we will use today. So let me go back to my terminal and install them by typing npm install, save, and now Express, that's the web framework. Cookie-session, that is the middleware of Express framework that will handle cookies for us, and Forge-APIs. That's the official Forge SDK for Node.js language. That may take a little while. And that's it. So now if I take a look at the content of my folder, I no longer have just package.json, but I also have node modules and package.log.json file. Node modules is basically a cache. That's a local folder that will store all the dependencies, the code for all the dependencies you install, and also for their nested dependencies, because ultimately you can imagine that Express itself may depend on other Node.js modules, and Forge APIs may also depend on other dependencies. And all this potentially a complex tree of dependencies is then flattened and stored and cached inside the node modules folder. That's why, even though we only installed 3 dependencies, if you look inside the node modules folder, you can see that it has lots of different dependencies. So this is a flattened tree of all the dependencies. All right, that's for the Node.js project setup and dependencies. What I'm going to do now is I'm going to switch over to Visual Studio Code. I'm going to say open folder, and I'll navigate to Bootcamp day 2. I'm going to open the Hubs browser folder, right? Whatever you named your project folder, just open it in VS Code, double click it, so that you can actually see the package.json file, and then click open. You may get prompted whether you trust the authors of this folder and its content. So we say yes, and we're good to go. Right, so we see our package.json file. That's the one that was generated automatically by running the npm init command. And we also see that it captured the dependencies that we installed using the npm install command. So we're using these three dependencies. And since we didn't specify any actual versions of these dependencies, the npm install tool captured the current version of the dependencies that we installed today. This is also important because to specify versions, because later on, if you want to share this code with somebody else, you will only send them your source code and the package.json file. You will not be sending them the node modules folder, because that's only meant to be a local cache. And let's say if somebody else wanted to run your code 1 year later, maybe there's going to be new versions of cookie session dependency, a new version of the Express framework, a new version of the Forge APIs SDK. And those may not be backwards compatible. If you imagine 1 year later, there is a version 6 of the Express framework that maybe works differently. So our code could actually break if somebody tried to run it 1 year later. That's why the versions are really important, because there is a convention that there's always 3 numbers in a version when we're looking at any Node.js module. And these are called major number, minor number, and patch number. Major, minor, patch. It's called semantic versioning. And this convention says that any dependency, any library from NPM or anywhere else should only bump up the largest number when there are breaking changes, right? So that basically means, and then the minor number should only change when there are new features added to a library, but they are not breaking backwards compatibility. And the third number, the patch number, should only change when there are some fixes being applied. That basically gives you some sort of confidence that later on, even if, let's say, next month, there is a new version of Express, number 4.20, 4.20.5, let's say, you know that you can still use it with your code, because the highest number, the major version number, is still the same. It's 4. That means that there are no breaking changes. So you can be confident that you can actually use anything, 4.anything, going forward. So that's why the versions are important. That's why they're captured here in the package.json file. All right. Let's go back to our tutorial. And let's take a look at the application config. Now, again, it's a good practice to structure your code into separate files, as opposed to smashing everything into a single JavaScript file in Node.js. And so we start by creating a config.js file in the root of our project folder. You can actually use this copy button on the tutorial website. I'll just create a new file called config.js, paste the content, and let me quickly explain what this code is doing. We're using this process.env way of accessing environment variables that were passed to our application. So this is how we typically configure server apps, whether you're using Node.js or Python or .NET or any other language. Typically, it's quite common to pass configuration parameters to the server application when it runs through environment variables. And specifically in Node.js, the environment variables are accessed through this global object called process. Process contains all sorts of information about the operating system process where your Node.js application is running, including some stats on like how much memory it's using, including methods that can be used to, for example, exit the process, and also including this env property. So the env property is an object that simply contains keys and values for all the environment variables that are available in this specific process. And the syntax you see here is something called destructuring in Node.js. This is where we, instead of storing, let's say, Forge client ID equals process.env.forge client ID, we could do this for every single environment variable that we're interested in. But instead, we just use a single line where we use the curly braces on the left side, which is basically the destructuring, where we cherry pick certain properties, certain keys out of this process.env object. So we extract these 5 environment variables, and then we check for those that we know that are required, that we're going to definitely need, we check if they're defined, and if not, we immediately exit the application, right? So as soon as somebody tries to read some data from the environment variables using this config.js file, if those required variables are not available, we just exit the process immediately, and we just issue some warning in the console. As for the port number, we just say we can either take whatever port number is defined as an environment variable, or we default to the number 8080. And we also specify 2 lists of tokens, token scopes. So this is again going back to what I was mentioning earlier, where as you are requesting some sort of token, whether it's using 2-legged authentication or 3-legged authentication, you'll always want to specify the capabilities that the token will have. And it's a good idea to generate multiple tokens, one that has more power, more capabilities that you will keep private only in your server application, and then to generate another one that can be shared with the browser, for example, for the viewer, because the viewer that will run in the web page in a browser will need to have some sort of a token to communicate with Forge as well. So that's why we recommend creating 2 tokens, one that that will have some potentially more or different capabilities, different scopes. In this case, it has the data read capability. So this means that the token created with this scope will be able to read data from Forge, basically. And then we create another scope called public. And this is the one that only has a single scope called viewables read. So this scope only allows the token to read some conversion outputs from Forge when somebody uploaded a design file to Forge and Forge extracted information out of it. This scope will allow the token to only read that extracted information, not the original data, the source data. And then we expose all of these environment variables and our custom config, the scopes and port number, we export them as individual symbols out of this config.js file so that we can import them into another Node.js script. All right. I'm going back to our tutorial. Now this part is specific to those of you using Visual Studio Code. In different code editors, you have different ways of configuring like a debugging for an application. In VS Code, you use something called launch configurations, and you configure them using JSON as pretty much everything else in VS Code. You don't have to create this file by hand. What I'd recommend, here's what I'd recommend. We can maybe shuffle things around a little bit here. Create a new script in your project folder called server.js. This script is where we will eventually implement our Node.js server application using the Express.js framework. And it's going to be the entry point to our application, right? So this is going to be the file that is actually going to run when we want to start our Hubs browser application. And let's do one more thing. Inside the package.json file, you'll see scripts property here, which is an object that may specify various types of scripts, either with custom names or with some conventional names that can then later be used for convenience. If you're in Visual Studio Code and you type double quotes here, you will actually get IntelliSense showing you some of the existing script names that exist that can be defined here to control what happens when somebody installs your package or when somebody starts your Node.js application. Let's add the start script. This is basically saying what should happen when somebody wants to run my Node.js app, right? You don't want that the other developer to go through your code and try and find out what could be the file that actually needs to be started, or what is the right way of starting this particular application. So it's a good practice. Also, what I recommend doing is adding the start script. And if we want to start our application, we basically want to run the Node.js runtime with the server.js file. So this already is going to be a good indication when somebody else, some other developer reads our code, they can see this start script and they can see, okay, so the right way to start this particular application is by running Node server.js. So this means that later on, if somebody is using a terminal, that they can npm start. They don't need to figure out what's the right way to start the application. They can just type npm start, which is like a convention, a typical way of starting an application. And now the server.js script gets executed, even though there is nothing in it yet. All right, and now what we can do is can switch over the run and debug sidebar in VS Code and use this create a launch JSON file. So you could either create one yourself, or you can ask VS Code to generate this file for you. And this is the file where you will define your launch configurations. So different ways of running and debugging this particular application. So I don't want to specify, I don't want to write this launch JSON file by hand. So I'm just going to click this link. Now VS Code will ask me what type of application I actually want to debug here, right? So maybe I want to debug a Unity app, but here I know I want a Node.js application. So I will choose a Node.js application, and at that point, Visual Studio Code will create this launch.json inside a .vs Code subfolder with this default launch configuration setup. And what we can do here is we can specify, how we want to call this particular launch configuration. So we can call it launch my server, for example. We can specify which files should be excluded. Here, we can specify what program should be executed. And this could, I believe this should be the file, the path. Let's see. Oh, okay, we can actually take a slightly different way. Let's do this. Let's grab this launch configuration from the tutorial website, because it might be even more convenient, and replace it here. So what this launch configuration is saying is, we call it launch server. We want to use Node.js to debug this application. And the way we want to actually start our app is by running npm start. So there are a couple of different ways how you can configure a launch configuration for Node.js or any other runtime or any other programming language. But this is a good one because then we only have a single place where we define how our application can be executed. And that is inside the package.json file as the start script. So here, again, any other developer reading my code will know, okay, this is how I run this application by running npm start. And also, Visual Studio Code will know that it just needs to run npm start in order to start the application and debug it. Okay, and one more property we add here, which is really useful, is the env file or env. There are two ways. You can either specify just an env property, which is an object where you can define all the different environment variables that you want to pass into the application that you're debugging, or to separate these, to separate the actual sensitive data out of this JSON, you can use the env file property. And that one is basically a path to a file where you define your environment variables on separate lines using key equals value syntax. So that's what we're going to do here. We're going to create a new file in our project folder called .env. And this is where we can start defining Forge client ID, Forge client secrets, and all the different variables that we know that our application will require. So if you remember, the ones we'll need are Forge client ID, Forge client secret, Forge callback URL. Now, this is important again because this is the callback. This must be the same URL that we've configured on the Forge website for our application, because when we redirect the user to the login page, to the Autodesk login page, we will need to include the callback URL where we want to be redirected back. And if for any reason the callback URL is different from what we've configured on the portal, then we will get an error. Autodesk will refuse to authenticate the user because we haven't asked Autodesk to redirect the user to the same callback URL that we actually configured here. Okay, so the Forge callback URL environment variable must be exactly the same as the one we configured on the developer portal, and it must be this HTTP localhost 8080/API/auth/callback. Okay, so now what I'm going to do is to actually set this up correctly. I'm going to switch to my Autodesk account, because I learned yesterday that my private Forge account was expired. So what I'm going to do here, I'm going to grab another Forge application that I created under my Autodesk account. I'm going to grab the client ID and client secret and add them to my .env file. Again, one thing I was saying yesterday, you don't want to share your client secret with anybody because that's your application's password. So if somebody knows your client ID and client secret, somebody else could be making requests to Forge on your behalf. So you definitely don't want to share these. I have to share the client secret here because I'm showing you how it's done, but that is all right, because what I'm going to do after the presentation is I'm just going to hit this regenerate button, and that will create a new client secret. So the old one will stop working. And here, since I'm using a different Forge application, I'll also need to update the callback URL. So again, it has to be localhost 8080/API/auth/callback. Save changes. That should be it. And there were a couple more environment variables that we're expecting, or at least one required, and that's the server session secret. Now, server session secret can be any value you want. It can be up to you. This is just a string, an arbitrary string that will be used to encrypt and decrypt the session cookies. Because when we store the information about who you are when you log in, and when we store this information in the cookies, we don't want to just keep the information readable in the cookies, because again, that could potentially be a security hole, as somebody else could find the tokens, let's say, from your browser's cookies. That's why we use any arbitrary string that we provide through the server session secret environment variable to encrypt and decrypt the cookies that we store on your machine. Yes, there is a question. Should I select all the APIs in a Forge app when you create one? Yes. I'm guessing there might be some special use cases where maybe you want to limit the APIs that you want your application to have access to. But by default, I would just suggest to enable everything. Enable all the APIs. Okay. Let's go back to this one. Back to our tutorial. And now we can start building our server. So we're at the create basic server section in our tutorial. So let me once again copy this code snippet and place it inside the server.js file in Visual Studio Code and explain what this does. Okay, so what we're doing here is we're importing some of the dependencies. We're importing the Express.js framework itself as a Express object. We're importing the cookie session middleware as well, and we can give it whatever name we want. Here, we just decided to call it session. And we are, once again, using destructuring to import some specific values from our config.js file. So here we've exported a bunch of constants in this case. And in the server.js file, using the destructuring syntax, we cherry pick just the port and server session secret values out of this config.js file. And on the next 4 lines, what we do is we instantiate our Express web application, web server, and we set it up. We add a couple of middlewares. So these are, again, the middlewares, again, like these short functions that you can put into a stack that will process every incoming HTTP request. So we add 2 middlewares. We add one using this express.static call that is basically adding a middleware that will look for any incoming requests that look like they're requesting some static files. And it will look for these files inside a folder that we tell it to. So in this case, we're telling the middleware to look inside a folder called www.root. We don't have that folder yet, so let me create it here. www.root. So any file that's inside this folder, this middleware will actually try and see if the incoming request is trying to request a file in here. And if there is actually a file with that name, this middleware will respond immediately. So imagine that we're getting a request to localhost 8080/index.html. What this middleware will do, it'll look inside the www.root folder. It will try and see if there is a file called index.html. And if there is one, it will respond immediately. So none of the other middlewares will be executed. So this is for serving static files. And the other middleware we're setting up on line 7 is the actual cookie session. So we call the session object here as a function, and we pass in some parameters. We pass in a secret, which is, again, some sort of a string that can be used to encipher and decipher cookies. And we're also specifying max age, which is the maximum age for a cookie to be saved for in milliseconds, or how long it should be valid for. So here you can see that we have 60 seconds, 60 minutes, an hour, and we have 24 hours. So we're basically saying that we want our cookies to be valid for up to 24 hours. You can change this to keep it at a different value. This is just I guess a recommended way. I think this is what we grabbed from the cookie session dependency recommendations. And finally, we're calling app.listen, which is basically starting the server app listening on a specific port. And when the server connects to the port successfully, we just output a log in the console saying, okay, we're now ready, our application is ready and listening on port, whatever we configured, the 8080 by default. Okay. And with this, we should be able to run our application. So if we hit the green play button next to the launch configuration that we've selected, right now there is just one, the launch server. Our app, when you switch to the debug console, you should see the application running. We can try and go to localhost 8080. But yeah, the application is running, it does respond, but for now it doesn't really know how to answer requests to localhost 8080 without any API, right? If we tried something like localhost 8080 foo.txt, the middleware, the static serving middleware would try and look for a file called foo.txt inside the www root folder, but it wouldn't find it there either, right? So we would still get information saying, okay, we don't know what you're asking for, right? We don't understand this URL. Okay, that is the scaffolding of our application. And the next step is can try and set up the authentication. Again, what we're going to do is we're going to implement any logic related to Forge in a separate file to keep things nice and structured. And then we will implement something called a router, an express router, which is this idea of an object that can handle specific requests to different URLs. And this router object can then be attached or mounted to different parts of the server application, different URLs, and it can handle similar groups of requests in different endpoints that way. So first, what I'm going to do is I'm going to copy, and we're looking at the access tokens section in our authentication step. I'm going to copy this code, and I'm going to go back to Visual Studio Code. I'll create a new folder called services, and under it, in that folder, I'm going to create a subfolder called Forge. So services/Forge is the subfolder where we're going to be implementing all our Forge-related logic. So I'm going to create a file under Forge called auth.js. So let's paste the code in and let me explain what this is doing. Okay, what we do here is we import a couple of classes from the official Forge SDKs. Again, using the standard Node.js require call and the destructuring syntax, we just bring in two classes, the auth client three-legged and the user profile API. These are two classes that can be used to communicate with different sets of endpoints in Forge. In this case, specifically in the Forge authentication service. And then we take our config.js file and we extract a bunch of the values that we will need here. We'll need the Forge client ID, Forge client secret, and the callback. And we also bring in the internal and public scopes that we want to be using when creating the tokens. And just like we created two sets of scopes, one for internal use and one for public use, we also create two authentication clients, one for internal use using the internal scopes and one for public use using the public token scopes. And the rest of the code here are a couple of helper functions that we will use in the rest of the application, in the express router specifically. We have a helper function here that will generate authorization URL. That is the URL where we will want to redirect our user once they click the login button that we will add on our page, for example. So this will be the initial step of the three-legged authentication workflow where our user, after clicking some button on our page, will be redirected to Autodesk servers, asked to log in, and to give permission to our application to access their data. Then what we'll do is we're going to create something. We're going to create a middleware of our own. So again, reminding everyone, and a middleware in the terminology of the Express.js framework is just a function that can look at every incoming HTTP request and do something with it. It can either ignore it and let it go through the stack, or it can react to it in a certain way. It can respond immediately, or it can at least get some information out of the incoming request and store that information in the request object. So we call this auth callback middleware. And this is a middleware that we will use when the user logs in with their credentials on the Autodesk website, when they give permission to our application and are redirected back. When they're redirected back to, in this case, localhost 8080/API/auth/callback, then basically we will intercept this incoming request and do something with it. And what exactly we'll do here is, as I mentioned earlier, if you remember, when the user is redirected back to our application, to the callback URL, Autodesk will also include a temporary code in the URL. And we will access this code using this req.query.code. The req, the first parameter to our middleware function, is an object describing the incoming HTTP request. We can use it to inspect the URL of the request, any special parameters inside the URL, or any query parameters. And query parameters are all the params in the URL after the question mark. So by typing req.query.code, we're actually trying to grab a code parameter that appears in the URL somewhere after the question mark. And then what we also do is we use another call on the three-legged authentication client, which is called refresh token. That's also a concept in the three-legged authentication, where maybe you want to be able to refresh a token for a user instead of asking them to log in again. And basically that's what we're doing here. We're we're exchanging the temporary code for an actual access token, storing it in this variable called internal credentials. And then we're also refreshing the credentials to generate a new token with public scopes. So with these two lines, we basically create new token with the internal scopes and new token with the public scopes. And what we do then is we store the tokens and the refresh token as well in this session object, the request.session. This object is there because we're using the cookie session middleware. By default, rec.session would not exist, but since we added another middleware to our stack, to our Express server application, the cookie session middleware specifically, there is now this cookie session object that you can read properties from, and you can set its properties, and those will be automatically stored in the user's browser cookies. So what we do is, after generating the internal and public tokens, we store them in this session object so that these values, all these properties will be stored in the browser cookies. And we can also read from this object later on, as you'll see. So there is one, that's the auth callback middleware function. And then what we do is the middleware function always accepts three parameters: the request, the response, and a next function. And by calling next, we basically pass control to the next middleware in the stack. We don't want to respond immediately. We just want to give control to the next middleware in the stack, because other functions in the stack might actually react or handle this request in a certain way as well. Another helper middleware we're creating is the refresh, authentication refresh middleware. So this one will be used, first of all, to check if the user is actually authenticated. And we do that by looking inside the rec.session object and see if it has properties like refresh token and expires at. If it doesn't include these properties, we don't call next. We don't give control to the remaining middlewares in the stack. We actually respond immediately with 401. We close the connection and we return. So what this means, wherever this middleware will be placed in the stack, if the incoming request does not have refresh token value inside the session, meaning that if the user did not log in, we will return 401 unauthorized. Right, so this middleware will be used as a gateway wherever we place it. Whatever custom router we place it to, the code in that router will only be executed if the user is logged in. And then what we do is we also check if the expiration time, which we also grab from this cookie session, if by any chance it's already expired. And if it did expire, we refreshed both tokens, both the internal one and the public one, using the refresh token. And we update the tokens in the cookie session again, so that when this request is sent back to the client in the response, the cookies will be updated as well with these values. And that's pretty much it. That's what this middleware is doing. And then just for convenience, so that we don't need to go into request.session.public token or .internal token, we create a new object, new property on the request object. That's what the middleware typically do. Just like the cookie session middleware is creating the session property, we are creating this internal OAuth token and public OAuth token property that stores the actual token in the way that it's needed by different by other forge calls. All right, that is for the authentication refresh middleware. And finally, we're adding a helper function called getUserProfile, which will use the user profile API class from Forge SDK to get information about the currently logged in user. So we will use this later in our application to, for example, when the user logs in our app, the login button should disappear, and there should be instead a button saying something like logout, and maybe we want to add the name of the user inside the button title. And that is it. We export these helper functions from our auth.js script, and we can now use them in in a router. Okay, let me grab this code from server endpoints and go back to VS Code. We're going to create a new folder called routes. That's where we implement all our Express.js routers. And under there, we're going to create a file called auth.js as well, and paste the code. So with this, we're basically implementing an Express.js router that can be attached to a certain endpoint prefix, to some path, URL path, and it can be attached to it to handle requests to that prefix followed by something. So for example, if we take this router object and we attach it to /API/auth, then this code will be executed for any requests to API/auth/login. So you can specify get or post or put requests. In this case, we only handle get requests to specific URLs. So if somebody makes a request to /API/auth/login, what we'll do is we will redirect, we'll call this response.redirect method, to redirect the request to another URL. And that other URL is the one we will create using the Forge SDKs. That will be the URL pointing to some login form on the Autodesk website. And when somebody makes a request to the API auth logout endpoint, what we'll do is we'll simply set the request session property to null. So this basically means we will clear any cookies, any session cookies, because after we redirect the user back to the index page, the cookie session middleware will see that we actually deleted the rec session object, and the cookie session middleware will react to this by clearing all the cookies, all the related cookies in the browser, in the user's browser. Now for the callback, if you remember, API/auth/callback is the callback URL where we will be expecting the user to be redirected to after logging in on the Autodesk website. So here, instead of having any custom logic, what we do is we insert our middleware function right into the router that get method call. So this basically means the router itself will not do anything special when it finds an incoming HTTP request to API/auth/callback, but our function, our helper function from services/fork/auth will handle the incoming request. It will look at the code query parameter, exchange it for an access token, and it will store the access token in cookies. After that, after the auth callback middleware did all the job, all the work, the router itself here will just redirect us back to the index page. So after we are redirected to the callback URL, to API/auth/callback, we just store the access token in cookies and we redirect the user back to the front page of our application, the index page. And for the remaining two endpoints that our router will handle, this is going to be the API/auth/token. This is the endpoint that our client-side browser will use to receive the public token for the viewer. So what we'll do is we'll simply use the refresh middleware. That's the middleware, the other helper function that we've implemented, that will first check if the user is logged in. And if not, this middleware will automatically respond with 401, meaning not authorized. And this helper middleware will also make sure to refresh tokens if they may be expired. And once the auth refresh middleware does all the main work, we just send a JSON back to the client containing the access token itself. And finally, if somebody makes a request to our server to the API auth profile endpoint, what we do is we request the user profile information for that particular user, and we just respond with a JSON object that includes a single property called name. That name is just the first name and the last name combined together. So that's what the router is doing. It's not doing a lot, right? It's mainly handling the three-legged workflow, and then it provides some information about a user that who logged in, that the access token was generated for. And then what we'll do in the server.js file is we will mount or attach the router to a specific path prefix. Let me grab this line and go to server.js and add that line here. So we're basically saying that we're mounting this router to /API/auth. So the router itself, when we look inside it, these are all just these are not the complete endpoints that the router will be will be handling, right? These are actually, you can think of these, you can prefix all of these with /API/auth, because that's where we attached the router. All right, that should be it. So now if we try and run our application one more time, it still won't show a lot on the index page because there is nothing yet. But if we try and do something like API auth login, so if you remember, this call, this request to our server running on localhost should redirect us to Autodesk website, where we will be asked to log in and give permission to this application. So let's see if that works. No, well, there was an error, it looks like. Okay, let's see what happened there. Let's try one more time. API auth login. So we intercepted the processing of this endpoint by our Express app here. So let's step inside. Say, generate auth URL. see. Network. Okay, so we actually, when we went to log in, we were redirected to a different page. We were redirected to developer API authors.com, authentication, authorize, including scope data read, and including the callback, the callback URL localhost 8080/API/auth/callback. This worked. But then we were actually redirected back to our application, to localhost 8080/API/auth/callback with a temporary code. So this actually worked. But for some reason, oh, okay, I see what happened. So the process was too quick. So it actually succeeded, right? So after going to API auth login on localhost, I was redirected to Autodesk servers, but I'm actually, Autodesk servers already remember me logging in. So I was redirected immediately back to my application with this temporary code. Here you can see the temporary code was this EMMGN underscore something. And my application, my Node.js application here, did exchange this temporary code for an access token. But then if we take a look at what happens here, after it generated an access token, it redirected me back to the index page. And of course, we don't have the index page implemented yet. That's why we're getting 404. But we can try something. So this, of course, fails with 404 because we haven't implemented the index. But we should now be able to go to application in the browser DevTools and look at the cookies for our HTTP localhost 8080 URL. And as you can see here, this is actually the session, and session.sig are the two cookies set by the cookie session middleware. And we cannot read it really because it's encrypted. It's encrypted using that, arbitrary session secret that we defined, that we configured for our application. So we could also keep it, unprotected, just store the session data as is in the cookies. But it's a good idea to protect the cookies. And here, as you can see, this is actually valid until September 15th, so tomorrow. So the cookie is valid for 24 hours as we configured the middleware here. All right, so this confirms that our application so far is running well. We can log in, we can log out. Let's try the logout as well. We bring back the cookies. Now, if I say API auth logout, you see that we got redirected back to localhost, and the cookies, the session cookie is no longer there. So by logging out, we just clear the cookies, and just by clearing the cookies, we basically make the user login disappear, right? So now we're again appearing as a completely new visitor to our web application. And that is it for the authentication step. Okay, what do you think? Everybody following along? Everybody got their application running? Can they use the API auth login endpoint? Okay, see some thumbs up. That's good. All right, so I guess the question again is, what do you guys want to do next? Let me restart the poll. and see what you guys are thinking. If you want to take a break or continue. Okay, I see majority of people wants to take a 30-minute break so far, it looks like, which is fine by me. Okay, it's settled then. Cool. So we're gonna take we'll take a 30-minute break. Let's see what the time is. Let me close the poll. All right, so it's 11:53. So I'll see you all back here in in 30 minutes from now. And if you have any questions or any problems, drop me a note in the chat or in the Q&A, and I'll try and help you in the meantime. All right, I'll see you later. We're back for the third section of our tutorial and our presentation today. This point, we're going to be implementing some additional server endpoints so that then later on the client side, we can start browsing through the different designs and folders and projects that the user who has logged into our application has access to. How does the Forge data management service work? On day one, yesterday, we were using just the OSS layer, the object storage service, which is a very simple data storage option. But of course, then later on, you may want to start leveraging some of the higher level structures on top of your flat list of data. You may want to have different projects, and each project can have different, a separate folder structure with items and versions of these items. The data management service does provide these additional layers with the data service and the project service. Project you can think of as a specific, let's say, a project for a customer, like a specific construction project for a customer, for example. And a hub is typically a silo of projects within a specific product. So you can think of a BIM 360, for example, is a hub, and inside BIM 360, you can have multiple separate projects, right? And each project can then have its own folder structure with with items, designs, and their versions. And ultimately, all these still point back to some simple flat list of designs in OSS. Now, in order to be able to browse our hubs, projects, folders, and items eventually in our client side, we'll need to provide some logic for that on the server side, some information that the client side will then be able to query to give us this browsing experience. So what we'll do is we're going to add another helper script called hubs.js under services/forge subfolder. In there, we will capture the different types of queries or requests that we may need to make to Forge to get this list of hubs, projects, folders, etc. And then we will expose this logic through another router, as we did with authentication. All right, so let's switch back to our tutorials website, switching over to the data browsing section. Let me paste that in the chat again. So we'll start by implementing our helper functions for querying the Forge data management service. So let me copy this code and create a new file under services/forge, call it hubs.js. Services/forge, hubs.js. So again, once again, what we're doing here is we're bringing in some of the classes from the Forge SDK, Hubs API, Projects API, Folders, and Items API. As you can imagine, these classes we will use to make queries to Forge to get a list of hubs, to get a list of projects in a hub, to get a list of folders in a project, to get list of items in a folder, etc. And here we simply wrap these Forge SDK calls into simple functions like get hubs. All these functions will require a token because, of course, again, if we want to communicate with Forge, we will need to authenticate ourselves in a certain way. So this is where we will be including the access token that was generated for us after finishing the three-legged workflow when the user was redirected back to our website. So we have a helper get hubs function that just lists all the hubs that are accessible to a specific user with their access token, based on their access token. Then similarly, we have a helper function that will list projects inside a specific hub that, again, are accessible by a specific user. And later, we have another helper function, get project contents. This will actually be used in two different ways. Well, it'll always be used to list folders inside for a specific hub and project, but we can either specify a third parameter folder ID, in which case we will ask for a list of folders inside that specific folder ID, or we can leave it undefined, in which case we will use a different method, requesting the list of top folders right at the top level of a specific project. So you can see that if statement here that basically decides which way we go. If folder ID is not defined, we just ask for the top level folders for a specific project. Otherwise, we ask for the contents of a specific folder. And finally, get item versions. This is where we'll use the items API class and make a request to Forge Data Management Service to get the list of all versions of a specific item. So if you have a specific design in BIM 360 or ACC or Fusion Team, for example, these might have multiple versions. So this way we'll be able to list these versions as well. All right. And now we just want to expose this functionality in our server through another router. So let me copy the code and create a new file under routes, call it hubs. Paste the code in here. Now, what we do for this router, you may see that this strange construct that we didn't use before, we just call router.use auth refresh middleware. This is basically us configuring, inserting a middleware even inside a router. So any incoming requests that this router will handle, all the incoming requests will go through this middleware as well. And if you remember, auth refresh middleware is the one we'll use to, first of all, check if the user is logged in, because we want to make sure that these endpoints are only accessible for users who are logged in. And second, the auth refresh middleware also makes sure that if the token that we have stored for the current user in the cookies, if it's expired, we can still use the refresh token to update the access token, make it valid again. So that's what we're doing with the router.use. We're not defining any logic for a specific get, post, or patch request. We're simply inserting a middleware that will always be executed for any requests handled by this router. And after that, we actually have a list of endpoints that this router will handle. So for example, any request to whatever prefix we attach this router to, we will execute this code. We will get a list of hubs based on the current token that we have for the specific user, and we will return them as a JSON. And similarly, we will handle another specific endpoint. Depending on where it's attached, the endpoint will end with /ID of certain hub /projects. If we detect this type of request coming to our router, what we'll do is we will request we'll get the list of projects under that hub and return it as a JSON again, right? So this is where we take the helper functions that we've prepared for the communication with the Forge data management service, and we simply expose them as endpoints of our server. Similarly, and here again, just to remind you, this special syntax in the path with the column, this is what makes this part of the path dynamic or variable. So you can think of it as a wildcard. This can be any arbitrary value sitting in a path, and then we can actually obtain the specific value from the URL by using the request params object. So here, by typing rec.params.hubid, we can actually get the value that the matching system found at this point in the path, in the URL path. And for this URL, we're going to be requesting the contents of a specific project in a specific hub, so that we actually have two variables, two URL variables, and we again access them through the rec params hub ID and project ID. And we also can see here, we try and access a folder ID, which is another parameter that can be passed in the URL as a query. So once again, query is whatever is after the question mark, right? So later on, let's say if we mount this router to the /API/hubs prefix, this router handler could handle endpoints looking like this, and some hub ID projects, and some project ID contents. This is what the URL could look like that will be handled by this code. And also it may come with a query parameter called folder ID equals something like this. So this is optional, right? If it's undefined, if you remember, we will list the folders of the entire project, the top level folders in a project. And if it is defined, we will simply make a request to Forge Data Management Service to get a list of all the folders and items inside a specific folder. So this is the type of URL that this code will be able to handle. And finally, having a complex URL. Now, after we drill down to a specific hub and project and item, we'll also support a request for listing all the versions of that specific item. And that is it. Now, again, as usual, we just need to grab this router and mount it or attach it to our server application. So I believe, let me double check. I believe it should be mounted to /API/hubs. Yes. /API/hubs. And this is how we mount the router to the API hubs prefix. So again, the router will then be able to handle requests like API/hubs/hubid/projects. Okay, well, let's see if we can test it out. Still without the user interface, but that should not be a problem. I go to localhost 8080. Let me open the cookies. I see that there are no cookies for me, which means that I'm not logged in yet. Like, at least the server still doesn't see me as a logged in user. So what I'm going to do is I'm going to go to API auth login. Now I've been redirected to Autodesk, where Autodesk remembers me already. So Autodesk redirected me back to our server application on localhost. And now from our application's perspective, I'm already logged in because I see that the server has already stored a session cookie in my browser. So with that, I should now be able to say API hubs to get a list of all the hubs that my specific Autodesk user that I logged in with has access to. So hopefully there are going to be some. And there we go. So we actually have a single hub that my specific Peterbras user account has access to. You can typically tell what type of a hub, what type of product it is based on the ID. If it starts with A dot, that is typically Autodesk 360 or Fusion Teams product. If it starts with B dot, that's a BIM 360 product. You can see that this actually explains that this is an Autodesk A360 personal hub. And you might get some additional information in the JSON as well. So we're basically just sending request to Forge Data Management Service saying, hey, we have an access token from this user. Please let us know what are all the hubs that this user with this token has access to. And we just grab the response from Forge and directly send it to the browser from our application. So this is the raw JSON unmodified that we received from the Forge Data Management Service. This is cool. So now what I can do is I can actually grab this hub ID. And if you remember, we implemented another endpoint where we can get a list of all the projects inside a specific hub. If I say API/hubs, and I use the hub ID/projects, boom, I get a list of projects available in my A360 personal hub. So even though I did not set up any custom integration for a specific BIM 360 project or BIM 360 account or ACC of Autodesk Construction Cloud account, I can still see some kind of hubs and projects that I have access to. So you can see that there is one project, there is a ICT tracker demo project. And now, so what I can try is I can grab the ID of the project and extend my URL. And I believe we use the word contents. That way we should be able to retrieve a list of top level folders in my project. What happened here? Ah, there we go. Okay, so we're in, we see a folder called a demo project, and then we could go deeper and deeper, right? I could grab the ID of the folder and add it as a query parameter. Folder_ID, I believe is what we called it. And this way we can get the list of all the contents inside this specific folder. So I see that there are some items. There's an item called animated box. There's an item called jet engine model, carbon fiber cylinder. So we can see we can already browse through some of the projects that my Peterbras user account has access to, even just using URLs and endpoints without having any visuals, any tree for it yet. So that's a good sign. That means that our data browsing code is working as expected. I see we have a question. We have a question saying my API hubs route returns an empty array. What does it mean? I have a free trial on BIM 360 docs and have already added a Revit file. Okay, so if you're getting an empty list when going to API/hubs, that means that yes, by default, the Forge Data Management Service does not see you having access to any of the products. So one thing you can try is, I would recommend if you go to, let's see, if you go to a360.autodesk.com, you actually be redirected to Autodesk Drive, which is now makes me wonder if you would actually see the data from Autodesk Drive. Or let me, let's try something else. Autodesk360.com. Fusion team. So right, so this is, I think, something you might try if you're not seeing any hubs. I'd recommend going to Autodesk360.com or to myhub.autodesk360.com because this is the hub and the projects you saw me using, right? So getting in when testing the server endpoints. I think that you should be able to get access to Autodesk360.com as a private user, I think. And that way, these projects could then appear in the list. And what you were saying in the question for BIM 360, as I said earlier, BIM 360 by default will not let your application see its data. BIM 360 has an additional security measure where if you have a BIM 360 project that you would like to see in your application, you actually need to whitelist that application's Forge Client ID as a BIM 360 admin. For that, I would refer you back to the Getting Started section of the tutorial. Let me send you a link. So once again, this part of the Forge Tutorials Autodesk IO website explains what needs to be done if you want to see your BIM 360 or Autodesk Construction Cloud projects in your custom Forge application. So for Fusion teams, nothing is needed, right? Your Forge application can automatically access the data if you have any data in Fusion teams. That's the Autodesk 360 website. But for BIM 360 or Autodesk Construction Cloud, again, you'll need to go through this process as an admin, BIM 360 admin, to add a custom integration. When you add a custom integration, again, you'll simply need to enter the Forge client ID of your own application that you want to enable access to your user's data, right? When that custom integration is added, at that point, when you log in and you make this request to Forge saying, tell me what are all the hubs that this user has access to, then you should see the BIM 360 projects there as well. And also one note, I just remembered, I believe, I'm not sure how exactly what exact requirements are today, but in order to actually see this custom integrations tab under the account admin, I think that the BIM 360 account has to be switched into developer mode, I think. And how that works, let me check. BIM 360. BIM 360 APIs. Here, okay. So I'll send you this link as well. This explains the process to actually enable the developer mode on BIM 360 if it's not enabled already, because I believe that is something that's needed in order for you to actually see the custom integrations tab under the settings. So let me send you this link as well. Or again, you could try going to my hub, Autodesk 360, 360.com. I think this should work as well. So you could try and upload or create some project and upload some designs in A360, formerly now known as Fusion Teams. And those projects you should then be able to see in your own project, in your own Forge application as well. Awesome, you found, so if you find the custom integrations tab under the account admin, that's perfect. That basically means that all you need to do at that point is just grab the client ID of your own Forge application and add it as a custom integration. And at that point, when you log into your custom Forge app, you will see the BIM 360 projects there. All right, that is it for data browsing. Has everyone been able to get this working? Can you, when you try the API hubs requests, when you test the server, do you see any information there? Any hubs? All right. So now we're in front of the last section of our tutorial today, and that is actually implementing the front end piece that will make use of these endpoints that we've just implemented. And it will provide a simple tree browsing experience and Forge viewer that will show us, that we'll be able to preview the designs that we select in the tree. So again, let me ask you, how do you want to proceed? Let me start the poll again. Let me know if you want to take a break or if you want to proceed straight away. Oh, wow. Okay. Now it looks like we're actually getting more people interested in continuing straight away. So let's wait for a little bit more to give the rest of the people a chance to vote. All right, so we don't have a perfect winner. It looks like the majority of people want to either take a 15-minute break or continue right away. So with that, and some people would like to take a longer break. So let's find a compromise and let's take 15-minute break for now. So it's 12:50 for me. So I'll see you all back here at 1:05. So 50 minutes from now, I'll be back here and we can jump into the viewer and UI section of our tutorial. All right. We're back for the final segment of our presentation today, of our webinar, where we will take all the work we've done so far today and tie it together by implementing a front-end piece that will use all the different endpoints that we've added to our server and use it to provide some nice, simple user interface for our users to be able to browse through their hubs and projects and to load the selected models designs into the viewer. All right, how this will work, just like on day one, we will implement some of the viewer logic. So a quick way to initialize the viewer and to load a model into the viewer. We will implement and capture that logic in one file that will be the viewer.js file. Then we will implement some logic to control and to populate the tree, because we're going to be using a third-party dependency for the tree view. We will capture that in a sidebar.js file, and then we'll glue everything together with some application logic that will decide whether we show a login button or a logout button, depending on whether our user is logged in or not. And that application logic will also instantiate the tree, instantiate the viewer, and it will connect these two so that when the user selects something in the tree, we will load the corresponding model in the viewer. That'll be in the main.js file. And we'll put all this into a simple HTML markup and add a little bit of CSS seasoning on top of that. And all these files will be stored under the www root file, because again, if you remember, that's where we configured our middleware for serving static files from. Okay. So let's go back to our tutorial. Viewer and UI. So this is the page we're going to be covering right now. Let me send it to the chat. And let's get started. So again, for the viewer.js file, we just have a helper function to initialize the viewer and to load a model into the viewer. Initialize the viewer, we're using the viewer APIs. When you import a viewer 3D.js file in your HTML markup, I'll show you how that is done. You will get access to some classes under the Autodesk.viewing namespace. That's where really all the viewer API classes and methods live. And there is a global function called initializer. So Autodesk.viewing.initializer is how we can actually prepare all the dependencies for the viewer itself, because the viewer may require some additional files, some additional resources, icons, background images, things like that. So with this async function called Autodesk.viewing.initializer is how we can give the viewer a chance to fetch and download all these dependencies. And when that initialization is done in a callback function, we can then create an actual instance of a viewer, host it in a specific HTML element, and we start the viewer and set its theme just to have maybe like a white toolbar instead of the default dark one. Okay, so let me grab this viewer.js code and let's add it to our application. I'm going to go into the www roots, create a full file called viewer.js, paste the content. So again, we have our init viewer function used to initialize the viewer. You may see here this get access token. This is going back to what we were mentioning at the beginning, where if you want Forge viewer to be able to load a model from somewhere from Forge, the viewer needs to be able to provide some sort of a token, because the viewer in this case, the viewer will be talking directly to Forge servers. So in order for the viewer to be able to actually access some of the data in Forge, in the Forge model derivative service, the viewer needs to have some sort of token as well that it can use. And this is something that the viewer typically leaves to the developer to provide. So the way it's done is that when you're initializing the viewer, you can pass in a function called get access token. And the viewer will call this function implemented by you whenever it needs a token to talk to Forge. So we provide this function here, get access token. And what we do is we just call the fetch, the built-in browser method for making a request to our own server. And we send a request to /API/auth/token. So this is where we get the actual public token with the public scopes, right? That's the viewables.read scope that we prepared on our server side that we can share with a browser. So we ask for the token, and if there is any issue with the response, we throw an error. Otherwise, we read the response as a JSON because we expect it to be a JSON, and we cherry pick the act token and the expiration time out of it. And then we just need to call a callback method that will be passed into our custom function as a parameter. And by calling the callback function, this is how we actually send this information back to the viewer, and the viewer will then be able to store the token and use it for any subsequent requests it makes to Forge. And finally, the load model function. This is how we will be actually loading something from Forge into the viewer. So it's not just a single line of code as someone might expect, because typically in Forge, when you upload and process a design, typically that design can generate multiple outputs, or in other words, the Forge model derivative service can generate multiple derivatives out of a single design file. The example I typically use is a single Revit file. When it's processed by Forge, the Forge model derivative service can actually generate multiple 2D sheets and multiple 3D views outside of that one single Revit design. So there is one too many mapping. And that is why you typically need a little bit more information if you want to load something into the viewer. First of all, what you need to do is you need to call the autodesk.viewing.document load method, by which you will load, the viewer will load the manifest JSON representing all the outputs that Forge was able to find or extract from a specific model, from a specific URN. And then from there, you need to choose which one of the outputs, which one of the 2D sheets or 3D views, for example, you want to load in the viewer. And what we do here is when the manifest, the document is loaded, so we provide two callback functions, one to be called in case of success and one to be called in case of a failure. And in case of success, what we do is we call this document.getRoot.getDefaultGeometry. This is basically the way of saying, okay, now go through the manifest of all the outputs that were extracted from my design file by Forge and grab the default one. And when we do that, we can then finally call this method on the viewer object called load document node. And this is actually the one saying, okay, we can now start loading a specific 2D sheet, a 2D drawing or 3D scene into the viewer. So this viewer.load document node is when the actual loading is kicked off. So that is for our viewer.js file. We go back to our tutorials. Now the sidebar, right? So as I mentioned earlier, we're using a third-party tree view component. So we'll need to have some sort of way to populate the tree. So let me copy the sidebar logic, sidebar code, and add it in a file called sidebar.js. And then, again, let's explain. Let's take a look at what this is doing. We can start from the bottom. We export a function called initTree that's going to be used by our application to actually initialize the tree in a sidebar. And here you can see we're using a third-party component called inspireTree. And this tree has its own way of configuration and way for you to configure the data that should appear in the tree. And one of the ways is through a function that you pass in as this data parameter. So data property can be a function that when called can return some list of children of a specific tree node, right? So initially it's called with a node being undefined to get a list of all the root nodes. So that's actually what we check in the first if branch here. So if node is not defined, or if node ID is not defined, we call our function here to get a list of hubs, and we return the hubs. So at the top level in our tree, we always want to see all our hubs, all the hubs that we have access to. Otherwise, if node object is defined and it does have some ID, we proceed and do something different with it. What that is, let's take a look. We have these helper functions here, like get hubs, get projects, get contents, get versions, right? These are, again, one-to-one mappings to the server-side endpoints that we've implemented to get a list of hubs, to get a list of projects in a specific hub, to get a list of folders and items in a specific project, or potentially in a specific folder within the project. And to get a list of all versions available for a specific item ID. So that's what we do here, right? All these methods just send requests to our server again. So API hubs or to API hubs /hub ID /project, projects, and et cetera, et cetera. So these are the methods that we then call inside the data function when we're initializing the tree, right? Because we basically want to make sure that the tree is populated dynamically, so that only when we click on a specific hub, only at that point we want to get a list of projects inside that hub. and populate a tree, right? We do not pre-populate the tree with all the data from all our projects, from all our hubs. We only fetch the data on demand when it's actually needed. So what we do here, we just use like a small trick where for each node in the tree, we generate some kind of an ID. For example, if we have a list of hubs, the ID that we create for each node is this is just our internal convention, hub followed by the pipe symbol, followed by the hub ID. And similarly, when we're generating a list of projects for the tree, we create a node for each project with the following ID: project, followed by pipe symbol, followed by hub ID, project ID. That's it, right? So we build our custom ID that represents what kind of tree node it is, whether it's a hub, a project, a folder, item, or a version. And then following the pipe symbol, we include the actual information about what's the hub ID, what's the project ID, what's the item ID, and what's the version ID, for example. All right, so this is all captured in this data function that we pass into the inspire tree component, right? So at the top, we start with a list of hubs. We return a list of objects that represent the top level tree nodes, and each node has an ID starting with hub to let us know that this is actually a hub with a specific hub ID. And later on, if we click on one of the hubs in the tree, we actually jump into this branch of the if-else statement, and we simply split the ID, the node ID, by the pipe symbol, and we see if the first of the split strings is hub, so we know that, okay, the user, now the tree is asking us to provide all the children of this specific hub node. So we know that, okay, we now need to get a list of projects for this specific hub. And we know that the hub ID is specified right after the pipe. So we know that we can grab the second output of the split method. And if the tree component asks us for children of a specific node that represents a project, we know that we need to call get contents to get the folders in that particular project ID. So that's what we do here. That's pretty much all this sidebar code is doing, just to have some way to populate the tree dynamically on demand, right, as we're clicking and expanding the individual tree nodes. And at the end, we also have we set up an event handler so that you can see, we can call this tree.on method to add an event handler to an event, for example, node click, which will be triggered every time the user clicks on a node in the tree. And what we do is we again take the ID of the tree node, we check if it starts with version, and if so, we know that the user actually clicked on a node representing a version of a specific design item. And in that case, we call a function, callback function, that can be passed to our tree as a second parameter. We call it with the ID of the object that was clicked on. And that is it. So the inspired tree is how we define the behavior of the tree. And then we actually return a new instance of an inspired tree DOM, which means that we will want to render the tree inside the HTML using the standard HTML elements in the DOM. It's the document object model. So this is how we initialize our tree. And again, if you want to learn more about this specific third-party component, you can head over to inspire-tree.com. You're free to use whatever other components you might already be familiar with. Here we decided to use Inspire Tree because it doesn't have any other dependencies. It's not jQuery based because we wanted to have these new tutorials be modern and clean without any older dependencies such as jQuery. All right. And finally, our application logic. Let me grab the code from here. That's the main.js file. So under the www root, create a file called main.js, paste the content. So what we do here is we bring in some of the functions from our other client-side JavaScript files, like from viewer.js and from sidebar.js. This is the function we implemented to initialize Forge viewer. And this method is what we'll use to actually load something into the viewer. And init tree is the method, the function we were just looking at, where we initialize the inspire tree third-party component. All right, and the rest of this code of our application logic, what happens here is we grab a reference to an HTML element by its ID called login. In this case, this is going to be a button, because eventually we'll have an HTML markup with a button with the ID login. So this, we just grab a reference to that button. And then what we try and do is we try and make a request to the API/auth/profile. So if you remember, this is the endpoint we implemented in our server application that should return the name, the first name and last name of our user. If a user actually signed into our application. Otherwise, if not, it should return 401 unauthorized. So what we do is we check if the response of this request is okay, meaning that it's not a for something error. This okay flag indicates that the response was actually valid, that it came back with a 200 code saying that the request was successful. And what we do in that case is we read the response as a JSON, and we change the text inside our button that will be in the top right corner to log out. Because in this case, we know that somebody has signed into our application. So we'll change the button to call it log out. And we also change what the button does on click. So we say on click, when somebody clicks on the button, we will redirect the user to API auth log out. So at this point, since we know that our user is logged in, we want to change the button's logic so that when somebody clicks on it, the button will actually log the user out. And the way to do that is for the for the button to redirect us to API auth log out. And since we're logged in, we know that we can initialize our viewer that will be hosted in another HTML element, in this case called preview. So we'll initialize the viewer, and we also initialize the tree. We initialize the tree, and the second parameter that we're passing into this method, into this function, is the callback that should be called whenever somebody clicks on one of the tree nodes. And if it's a version node, right? This is where we want this is what we want to do. We want to load a model into the viewer instance that we just created, and we want to take the ID of the node that the user clicked on. And this magical strange thing, this window.b2a, if you haven't seen this before, this is basically a way to base 64 encode a string. So this is also something we covered yesterday, because in order to be able to load specific objects from Forge into the viewer, you need to provide their so-called URN. And the URN is simply the original ID of an object in Forge, but it's base 64 encoded, because Forge, the viewer and the model derivative service that the viewer loads the data from, it needs to put the object ID into the URL of some of the requests. And the object ID may include some non-safe characters. It may include colon, slash, some other potentially weird characters that could break the URL itself. And that's why whenever we're working with the viewer or with the model derivative service, the model derivative service actually is asking us to base 64 encode any IDs of objects that we want to be loading, that we want to be working with. So that's what we're doing here. Calling this window.b2a function actually takes the original string, which can look something like ADSK dot I don't know, OSS colon / something, can have these weird characters. So by using this B2A function, we actually base 64 encode the string so that it's safe to be used. And then after that, what we do is, if there are any equal signs at the end of the base 64 encoded string, which is sometimes done for, I believe, for padding, we can remove these. We don't need these. So the URN that Forge viewer and the model derivative service expects is just the base 64 encoded string without the equal signs. So all this strange construction is just to say, take the ID variable, encode it into base 64, and remove any equal signs from the result. And that's it. The other branch of the if statement, if the response is not okay, that indicates that no user is signed into our application at this point. So what happens then, we change the text of the login button to say login, because nobody's logged in, so we want to allow the users to log in. And we change the on-click behavior of the button so that when somebody clicks on the button, the user is redirected to API/auth/login. So I hope this makes sense. So basically what we do in our application JavaScript logic is we send a request to our server to ask for the username of the currently logged in user, right? That's what we do here by making the request to /API/auth/profile. And based on what we get in the response, if the response succeeds, or if the response is successful, that indicates that somebody is signed into our application. So that's why we change the UI accordingly, right? So we change the name of the button to log out, we change its behavior, and we initialize the viewer and the site tree. But if the request to API auth profile fails, that is an indication for us that that there is nobody logged into our application in this browser page. So then what we do is we just make sure that the login button says login, and that after clicking on it, the user actually will be redirected to API auth login, which, if you remember, is what initiates the three-legged workflow, where when you go to API auth login, you're redirected to Autodesk servers where you can enter your credentials and give permissions to the application. And after that, you're redirected back to our server to the specific callback URL that we've configured, which is /API/auth/callback. All right. So now let's grab the HTML. We can take the CSS file. So let me just copy it and create a main.css file under the www root. This is how we style our application a little bit. So this is like the standard stuff where we reset any margin or padding so that the application actually takes the full area provided by the browser. And we take the header, sidebar, and preview divs and make them as absolutely positioned, which means that we can then specify their position and width and height. That's an easy way, relatively easy way of, if you want to like split your web page area into some predefined segments. This is one way to go about that. So we just say that the header should have some specific height, and you should cover the entire width of the area. The sidebar should be have a top offset right below the header, and it should cover 25% width of the entire area, and it should be offset from the left edge by 0 pixels, so meaning that it should be all the way to the left. And the preview div is basically going to be the remainder of the real estate, showing the then the preview is going to be is going to host the viewer itself. And at the end, we also specify some additional visuals for the tree itself. So here, for example, when we create the tree nodes, we also use their the icon-hub or icon-project CSS styles or classes to change the image that appears in the tree. So if there's a hub, you want to show some custom image. If the tree node represents a project, we want to show a different icon next to it. So that's what we do in the CSS file. Okay, and finally, the HTML. So let's create a file here called index.html under www root. And this is where we tie everything together. Right, so it's a simple HTML page. This is the header that is sitting at the top of the page. It just includes some kind of a logo and a title and a button that is now marked as hidden that will later appear, and it will either behave as a login button or log out button, depending on the state, the current situation that we're in. Then there is the sidebar that takes 25% of the left area on the left side of the available area, and the preview, which takes the remaining area of the real estate that's hosting, that's going to be used to host the viewer. So that this is really all to the actual markup and layout of our application. And after that, we just bring in a bunch of dependencies. We bring in the Forge viewer script. That's the viewer 3d.js file. And also it actually comes with a style sheet, style.css file. Then we bring in the inspire tree. That's the component we use to render a tree item, to define the behavior of that tree. And inspire tree DOM dependency is the one that actually renders the tree as an HTML markup that we can then insert into our HTML page. And I believe Lodash is a utility library that is used by Inspire Tree. That's why we're bringing it in. And at the very end, we're bringing our own JavaScript file, the main.js file, which behaves as an ECMAScript 6 module. So that's a new way of building JavaScript scripts for the client side, where you can use this import-export syntax. Here you can use a relative path to import symbols from other ES6 modules that might be available on the same page. So here at the very end, this is where we initialize our application. We check if the user is logged in, and if they are, we initialize the viewer and initialize the tree. And that is pretty much it. And here also in the head, HTML elements, this is where we bring some CSS styling for the Inspire tree component. And here's where we bring our own CSS styles from our main.css file as well. And just to drive the point home, these requests, this one, for example, when we're asking for /main.css or /main.js, these work because of the static file serving middleware, because when this HTML page is loaded into the browser will immediately look for any other files that it needs to download. So the browser will see that, oh, I need to grab this style.css from developer API auditors.com, and I need to grab this Inspire tree light min CSS from pkg.com. I need to grab this JavaScript file from here, this JavaScript file from here, and another JavaScript file from my own server. So what the browser will do, it will make a request to localhost 8080/main.js, for example. And our middleware here will see this incoming request you'll see that the incoming request is looking for something called /main.js. And this middleware will look inside the www root folder to see if there is a file called main.js. And there is. So in this case, this middleware will ignore all the other middlewares in a stack, and it will immediately respond to the request with the content of this file. And that is my cat telling me that she's probably hungry. All right, let's give it a try. Let me start the application. Let's go to localhost 80. There we go. So I haven't added any logo yet, so that's all right. So we'll just see an error here. There we go. Now our application is working, right? So the client-side JavaScript made a request to our server to request the profile of the currently logged in user. And this call succeeded and came back with a JSON saying that the currently loaded user is logged in user is Peter Braz. So the JavaScript main.js file basically considered, okay, so the user is logged in, so we can initialize the viewer and the tree. And this inspire tree third-party component, this is what it looks like. So when I click on a hub, or here, let's say a project, it will make a request to our server saying, please tell me what are all the top folders inside this demo project. There's one, and if I click on this folder, this will make a request to our server side saying, tell me all the folders that are available, folders and items that are available in this demo project folder. And we see that there is a bunch of files. And you can actually expand those as well and see all the different versions of these designs that exist. And that's it. And then when we click on, let's see if this one will work. And we can click on a specific version of a file, and the design will get loaded into the viewer. So we have a very simple application that I can now use to see all my hubs and projects in one place here, so that I can browse through all of my BIM 360 ACC Fusion Team hubs. I can load models into the viewer. And then again, I can use this as a starting point and start adding customizations to this application. Maybe I, again, want to grab this model and connect it to some ERP system, or some, maybe I want to load some Revit model and connect it to like a scheduling system. So maybe I would like to see another sidebar here on the right showing some scheduling data linked to whatever model I load, or whatever element I select inside the model. So again, think of this as a starting point, an application that you can then start adding your custom behavior, your added value to. And this is something we will take a look at tomorrow when we run the dashboards tutorial. That's where we'll actually take either this application or the one we built during day one, and we will start customizing the viewer. We will add some more buttons in the toolbar. We will add some custom UI panels. We will use all sorts of viewer APIs to check and set the state of the viewer, for example, to hide certain things, to color different design elements based on some custom metrics. That's really where the fun starts, because that's where you can then start customizing the viewing experience. You can bring in other data sources in the context of the data, etc. All right. Any questions? All right, so there is a question. My tree is empty and the login logout button is hidden. I checked the endpoints of login logout. They're working, but I don't know why the tree is empty after all. So there might be another issue. If you if the button doesn't show up at all, that basically means that this part of our main.js code is never reached, right? Because this is what should happen. When you open the page, we check if we can get some information about the profile of the currently logged in user. If we succeed, we say the button should say log out. Otherwise, we say the button should include the label login. And either way, after this if condition, the login, the visibility of the login button should be set to visible. So if the button does not show up at all, that means that the code here does not reach this line, right? So you may want to check the console because it looks like there might be something else failing here, which prevents this line to make the button visible. So take a look at that. If there's any issue, it should be reported to the console. And in the meantime, I see there is one more question. Thank you. What is to consider when deploying this app to Heroku? All right, good question. So again, when you later on decide to publish or deploy this application to somewhere, whether it's Heroku, Azure, or Netlify, really anywhere, of course, the callback URL is going to change. And that's where you need to change your settings, your application settings accordingly. So let's say that I want to deploy this application to Heroku. And let's say that the name of the application will be something like my hubs browser. So then your application will typically be visible under this domain, right, on this URL. Then, of course, you need to change the callback URL to look like this. My hubs browser, heroku.com, for example, /API/auth/callback, right? That part stays the same. The endpoint, the URL path, it doesn't change. The only thing that changes is that instead of localhost 8080, we now are running on, let's say, HTTPS myhubsbrowser.com, right? So if this is where you are deploying your application, the callback URL would have to be set to this form. And again, don't remember, it's not enough to just set the forge callback URL environment variable for the application itself. You also need to update or add a callback URL on the dev portal for your application. So the good news is that, like I was saying earlier, now you can actually add multiple callback URLs. So we can keep the original one, HTTP localhost 8080/API/auth/callback. We can keep this one for when we want to run and test the application locally, just like we do now. And we can also add a second callback URL for the URL where we actually are going to be deploying. Now, if we save these changes, both of these URLs should remain there. And with these, you are then free to use your application both locally by running it from localhost, let's say from Visual Studio Code, as well as accessing the application by going to, let's say, myhubsbrowser.herokuapp.com. All right, any other questions or comments? All right, so there was a typo. That's why the file could not be found. Awesome. I like these. Those are relatively easy to find usually. Great. All right, so with that, let's go back to our slides for some wrap up. So what's remaining this week is tomorrow I'll be doing another tutorial. This one's going to be joined for both the .NET and the Node.js developers, because it doesn't matter which language you use to develop the server side. you'll just be able to bring whichever of the apps you built this week, whether it's the one from today or from day one. And we'll start customizing the application, customizing the viewer, like as I was saying earlier, adding custom user interface elements, controlling the state of the viewer, hiding, coloring elements. That's all the fun stuff you can then use to, again, add your value to that basic design preview tool. And on Friday, my colleagues will once again lead individual tutorials for Node.js and for .NET for the configurators tutorial. That's the one where you learn about leveraging the Forge design automation service that can be used to create or modify designs even in the cloud. Okay, let's see. All right, thank you guys. This was fun, even though probably not that much fun with my voice. So if you need more help, we have, again, we're trying to provide different ways of helping. Typically, when you have any technical question, something that's not confidential, something that's not very specific, do take a look at Stack Overflow. If you ask, you can already find the same question being asked by somebody else, or you can ask a question there. And if you just give it one of these tags, Autodesk Forge, Autodesk Viewer, Autodesk Model Derivative, we'll get notified. We have a notification system. We'll get a notification that somebody is asking a question on a specific topic. We can jump there and help answer that question. Also, if you need help with something more individual, something more specific, or maybe something confidential, something that you cannot or don't want to share publicly, feel free to just go to the developer portal, to the support section, and use the get help form here. This will basically send us an email so that we can get back to you via email and provide and help you out, provide some technical support to your specific use case and situation. We also run other types of events like hackathons and accelerators. So I would like to make sure that you guys are aware that this is an option. If you look at the community section on the Forge dev portal, you'll see that we have different types of events. We have pre-recorded lightning talks and accelerators. And accelerators are, an accelerator is a week-long event where we invite you to come and join us with some kind of an idea, something you would like to build using Forge within 1 week. So it can't be anything crazy, but if you have some idea, something you would like to explore, like, would this be possible with Forge? Definitely let us know. It's a free event. It's either virtual. It's been virtual during the COVID times, but also we're planning to go back to live accelerators, which is much better. In those cases, we invite you to one of our offices around the world for the week, and we sit down there with you, and we're basically like your live Stack Overflow. We're answering your questions. We're trying to unblock you whenever you hit a roadblock so that you can actually implement that prototype within that 1 week time frame. We also blog about different topics. So if you go to forgeautodesk.com/blog, you'll find many interesting articles there. You can search by topics or products, by authors. If I look at my own blogs, it's like different things when we talk about, tips and tricks when developing viewer extensions, or the new streamlined functionality available in data visualization APIs. So we usually, when there are like some of these very specific use cases or features, then we usually blog about these. Like if I want to do a material swatch in Forge Viewer, how do I do that? So please check these out. There's some good, valuable information in these learning resources. All right. What will happen after the event? As I said earlier, these meetings, these webinars are recorded, and we will share the recordings on YouTube with you after the event, probably sometime next week. We also usually include the PDF slides that we used during each webinar, so that you can use that as a reference as well if needed. And what's really important for us is usually in the wrap-up email, we include a link to a survey, and we would really, really appreciate your feedback on this event, on the content that's presented, and even on the form and the way the content is presented. Please let us know. We are again trying to find the best way to run these online boot camps. We want to make sure that you can get the most out of these. So if you think that something was working well, let us know. If you think that something could be done better, or something that maybe didn't work as great, whether it's the content or the format of the event, please let us know. We want to know. Yeah. And the links, the accelerators, lightning talks, and blogs, I already mentioned these. So with that, it's all from my side. So thank you one more time for joining me today. And I hope that I'll see you all tomorrow. That's going to be my last presentation this week. The others will be led by my colleagues. And after that, I think I'm going to need to take a quick break and recover. But I'm really excited for tomorrow, because that's going to be all about the viewer. And that's something that I'm really, that's the part of the entire Forge platform that's the closest to me. And I'm really passionate about, the customizations and all the stuff that you can do with the viewer API. So I'm really hoping to see you all there. I think it'll be a lot of fun. So please, if you're not sure about tomorrow yet, please give it a shot. I think you'll be impressed with the level of customization that the Forge viewer library provides. And with that, thank you very much for your attention. Unless there are any other questions, I think we can call it a day. I'm going to go grab another cup of tea and get ready for it tomorrow.